All right, what is an absolute value equation? An absolute value is always, to me, the distance that a number is from zero. So it's distance. So what this is saying here, this is the absolute value of y is equal to 5. So I always think of a number line. So on a number line, try to draw a number line here. I want to know where that point would be located. Well, it could be located at 5 positive, because that has a distance of 5 from 0, and it could be at 5 negative, because that has a distance of 5 from 0. So your solution to this is y equals 5 or y equals negative 5. So those are your two solutions for the absolute value equation. Absolute value y equals 5. So that's kind of just to help you get started. But you always, when you see absolute value, I know you're taught that, oh, when you see absolute value, it makes everything positive. Well, the reason it makes it positive is it's a distance. It's a length. So, all right. So that's just generally what absolute value is. So let's take a look at an example. So let's say you had this equation, 2x minus 1 equals 5. Okay. Well, now we have an expression that has a distance of 5. So you really, if you think back to that number line, again, the expression, so here's 0, here's 5, and here's negative 5. So we have two distances that are 5, this way and this way. So that means we're going to have to solve that expression for two equations. So you would have 2x minus 1 could be equal to negative 5, because that's the absolute value in the negative direction, or 2x minus 1 could equal positive 5. All right, and so now it's just a matter of solving both of those. All right. So we'll go ahead and solve these. So if you get, you solve them just like normal. I'll try a different color. On this one we're going to add 1 to both sides, and so 2x equals negative 4, and then you're going to divide by 2. And so one of your answers is negative 2. Or you're going to do the same with the opposite one, which is you'll add 1 to both sides, and 2x equals 6. And so then we know x, if you divide both sides by 2, x, should show my work, x equals 3. And so those are the two solutions to this, and how you verify that is plug them back in. So one of them was negative 2. So if you plug negative 2 in here, just off to the side, so that'd be 2 times negative 2 minus 1. Well, that's negative 4 minus 1, which is negative 5. Well, the absolute value of negative 5 is 5. So it works. And then you could do the same with 3. 3 times 2 is 6. 6 minus 1 is 5. Absolute value of 5 is 5. So you've verified your answers. You should never miss these, because you can always plug them back in and see if what you have is correct. Okay, so let's add a layer of complexity to this. So let's say we did, we are doing an operation to the absolute value embedded within the problem. The first mistake people make is they distribute the 3 through. You really don't want to distribute through absolute values. That creates all kinds of havoc. So what you do instead is get your absolute value by itself. So you kind of treat this like it's its own variable, like y. So basically this is like solving the equation 3y minus 1 equals 8. So you'd add 1 and then divide by 3. So you get that y by that absolute value by itself. So I'll go ahead and do that. So I'm going to add 1 to both sides, just like a normal equation. And so you'd have 3 absolute value of x plus 2 equals 9. Then you'd want to divide by 3 instead of distributing it through the absolutes. And so the absolute value of x plus 2 in this case equals 3. So this is telling me, whoops, wrong way. This is telling me that the distance, whoops, and I forgot an absolute value symbol. The distance of that absolute value is 3 from 0. So we know that that has the possibility of being either negative 3 or it has the possibility of being positive 3. And then you solve both of those. So if you solve that, x would be negative 5 because you'd subtract 2 to both sides, and then same here, subtract 2 from both sides. And in this case, x equals 1. So those are your two answers, x equals negative 5 or x equals 1. And then you could put those on a number line if you wanted to. Here's 0, 1, 2, 3, 4, 5. You know, you'd have 1 there and negative 5 there. And so that's how you'd graph those. So really, that was kind of a fast example with a little more complexity. But what happens if it's less than or greater than symbols? And I'll show you a couple tricks that go with this. But this is the same thing. You have two possibilities here. You have the possibility that 2x minus 1 is less than 5. And, in this case, it is an and. You have the possibility that 2x minus 1 is greater than negative 5. So remember, when you divide or multiply by a negative number, you flip the inequality. Notice when we changed, switch colors, when we changed this negative 5, this 5 to a negative, it's basically like multiplying by a negative 1. It also flips the inequality. And so we're going to go ahead and solve that then. So let me put this back. Okay, so we'll solve both of these equations now, and you can solve them just like normal. So plus 1, and so 2x is less than 6. Then you divide by 2, and let me extend the page a little bit. Whoa, wrong page. And so x would be less than 3, and in our case, you'd add the 1, 2x is greater than negative 4, divide by 2, sorry, I'm jumping ahead, and x is greater than negative 2. So those are your two solutions, and we can go ahead and graph these. Let's make sure I have the right symbol. I do, okay. So we got a number line. There's 0, 1, 2, 3, 1, 2, 3, and we would, so if we wanted to graph this one, x is less than 3, so we'd go to 3, you'd have an open circle, because you don't count 3 as not part of your solution, but everything less than that is. And since there's an and here, we're looking for where both sides are true. And so we have negative 2, which would also have an open circle. And that's greater than, so it's everything to the right. So this, our solution is all of these numbers in between negative 2 and 3. And so when we go to graph we want to go check maybe our answers and see if this is right, I just usually check a few, like check 0. That's an easy one to check. So if you plug 0 in here, 2 times 0 minus 1, yes, that's negative 1, which is 1, which is less than 5. And you could check several of them just to see if you're okay. And so there's your solution. Now, one added layer of complexity here is this is an and we're looking for overlap. And so I usually combine my answer into one sentence. So it would be negative 2, then I put my x, and then I put my largest number, so smallest to largest, and then fill in the inequality symbol correctly. So crocodiles eating the x between the -2 and the x, and crocodiles eating the 3 there. So it's -2 is less than x is less than 3. You could also do set notation, which would be this, -2 to 3. I'm not going to get into that representation beyond. This is usually what I accept. I want the number line. I want the concise answer, and then I'll also, if you're a little more advanced, you're going to write it in set notation. Okay, and then the final example is this one. It's greater than or equal to 6. And again, we have two possibilities. And with a greater than, this time it's going to be or. Because you got to think about it. Absolute value, it has to be positive with an absolute value. So if it's greater than, it's going to be larger than the 6. So you have two places where that's bigger than. It's either to the right of 6 or to the left of -6. And that's why it's an or, because they go in opposite directions. In this previous example, less than 5, you're working from 5 down. And so you're working inside the graph. And so here's -5 to 5. When they're together, that's an and. And over here, where it's greater than 6, well, greater than 6 means if here's 6, it's everything bigger than that, and it's going to be everything smaller than that, because the absolute value of -7 is +7, which is bigger than 6. So in this case, when they go apart, that's an or. It's either side could work. And I have a little even better trick that my kids came up with, is whenever you have absolute value and you have a greater than symbol, or greater than or equal to, that's great or instead of greater. And if it's a less than symbol, or less than or equal to, it's instead of less than, they say less and. So then it helps them. It's just kind of a mnemonic that helps them figure out whether they should be using an or an and. It's probably better to logic it out, but that's a quick way to do it. Alright, so let's go ahead and finish this thing. So if it's greater than 6, again, we have two possibilities. You have 2x plus 4 is greater than or equal to 6, or, again, greater, 2x plus 4 is less than or equal to -6, because again you have to flip your inequality and change your sign. So then you solve both of those. So I'm going to subtract 4 from both sides, just like we always do. And so 2x is greater than or equal to 2. And let me extend the page here a little bit. And then you would divide by 2. And so our one solution is x is greater than or equal to 1. On the other side here, you do the same thing. You subtract 4. And so 2x is less than or equal to -10. And then you would divide by 2 on both sides, and x is less than or equal to -5. And again, this is an or. Alright, so if we graph that, then on a number line, let's go to black. And here's 0, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Just to kind of give us a idea of scale and what's going on. And so we'd start at 1 is greater than or equal to 1. So that would be a closed circle at 1. Greater than or equal to goes all the numbers to the right. And then -5 would be right there. And it's less than or equal to -5, so it's all the numbers this way. And so again, you can kind of see that if you wanted to test some of these numbers, plug in, pick the number 2, or pick the number -6. and see if they work. And they will. And in this case, since it's an OR, we don't have to combine them. And our final answer is this. Again, not that I want you to go get crazy into set notation, but the set notation would look like this. It'd be open circle infinity to -5, and we'd have a bracket, or bracket 1 to infinity, and we don't include infinity there. So the bracket means we include the number. So this hard bracket, it's just a bracket, but -5 is included in the solution when you have that. You can't include, this means can't include, and infinity, I mean, infinity is not a number, it's just something we're approaching. So you can never include infinity. It's not really a number, it's just a direction we're headed, basically. Oh, and I did screw up. I have one error, and this should be a negative infinity, because we're starting from the negative side of the number line. So again, in my class, I'm not really too keen on this, but if you get to that point in your mathematical career, it's good to know. And there's absolute value, crash course in absolute value.